Which ions are polyvalent? Well, this is a nice summary of the periodic table, at least for everything except the F block. And it shows which ones are, in fact, polyvalent. And wow, it's really most of them. Let's have a good look at this. This is important when it comes to naming compounds. You never know whether to say, phosphorus 3 chloride, or are we okay just saying phosphorus chloride? I think the proper way to do it is to never really make a deduction when somebody puts in the Roman numeral when naming it, because look at how many of these in reality are polyvalent. Okay, the group 1s are not, except actually hydrogen is. It can either be +1 or -1, right? The group 2s are all monovalent there, no exceptions. And as we work our way across this column, just about all of them, well, not all, but most, are really have multiple charges, right? Interestingly, the group 3b does not. It's monovalent. Group 4, look at that. Hafnium is always +4, and zirconium is always +4. Who knows this stuff, right? Who knows that tantalum is always +5? I didn't know that. We might have heard of the diagonal, where aluminum's always +3, zinc's always +2, silver's always +1. But there's more to it than that. Cadmium's always +2, indium's always +3, gallium's always +3. I think the bottom line is that it's appropriate to use the Roman numeral when naming something, really whenever you feel like it. So I suppose it's just nobody's going to write sodium 1 chloride. However, almost all these are polyvalent, and so there are lots and lots of polyvalent ions out there. And as time goes on and people do more research, what do you want to bet somebody finds some fleeting example of boron in the +2 state, for example? That kind of thing. So that's a little bit about oxidation numbers of elements in their compounds.